Welcome to Flink Forward Asia 2024.
We have another coffee break, but before that, let us complete with a presentation on Demystifying Flink Snapshot, a comprehensive guide for new users. That will be presented by Mr. Hong Liang Theo as Apache Flink Committer Senior Software Engineer AWS. Please welcome Mr. Hong Liang Theo.
Hello. Oh, cool. All right. Technical difficulties aside. Hi. Hi everyone. Salam sejahtera. I'm Hong, and today I'm going to be talking to you about Flink Snapshots. Right. So I'm actually quite excited to speak here in Jakarta because I'm actually from Malaysia, but I've been working in the UK since then. So I'm actually quite curious to see, I guess, and bring the knowledge that I have over here into the ASEAN region. So I think before I start, so I guess a bit about myself. So I'm an Apache Flink committer. I think that's not a very big title here because there are a lot of big PMCs, people who maintain the project here in Flink. But hopefully I can give a bit of my insight here. I'm also a senior software engineer at AWS. So I'll be working for the team that runs Flink in AWS. So hopefully I can bring some insights here as well and help, I guess, understand a bit better. So before I start, maybe I can ask a few questions. So how many of you guys have heard of Flink before you came to this conference? I don't know, just a raise of hand, just, oh yeah, all right, quite decent, heard of, all right, so first time hearing about Flink, okay. How many of you guys have used Flink before? I don't know. All right, so about the same people. So people have heard Flink, okay, cool. So hopefully, by the end of this session, you can understand a bit more about what the strengths of Flink and I guess be able to use it and test around with it in your own companies, right? So today, what am I going to talk about, right? So I'm going to talk about Flink Snapshots, right? So I think you've heard about it earlier in Sin Tong's talk, and I think one thing that's very big in Flink is state fault tolerance, right? So you can process data, you can maintain state, and even if your computer goes down, you'll be fault tolerant, meaning that the answer that you produce is consistent. It's always the same answer. Even there's some problem, your server spins up again, the answer it generates will always be the same. So snapshots are the way that Flink does that. So it's a very important feature of Flink. So this is how Flink does it. So I mean, one analogy I like to use is like when you're playing a game, you play a game, you're worried, right? You click the save button, save, right? Then if you have any problem, you go back and restore from your save, right? So that's what a snapshot is. It's clicking the save button. The question is, how do you do it in a Flink environment? So Flink is a cluster, it's a distributed system across many machines. So how do you click the save button? So yeah, that's what we're going to talk about today. So roughly, this is what I'm going to cover. So first one is, what is a snapshot? What is a state snapshot in Flink? How does Flink take these snapshots? And I guess there are different configuration and different types of snapshots that you can do. I'm just going to explain briefly. And I guess we've all heard about Flink 2.0 today and the new changes that are coming. So we'll touch a little bit as well on what's different in 2.0 and how you can appreciate that as a slightly different thing. So hopefully by the end of this talk, you'll go away and say, okay, I know what a Flink checkpoint is, I know what a save point is, I know how it's done, and I know roughly, I guess, what the changes are with Flink 2. So you can go around and play with it. So cool. Let's get started. So the first one is, what is a state snapshot? So to understand that, we first have to understand a job with state. Cool. So in here, the job, just imagine here, so this is like a simple Flink job. On the left to the right is how the data flows. And you can kind of see on the left, there's a source, right? So source is how Flink reads in data from external system, right? So imagine like a file system where you can want to read some data, right? And then you map. So map is a simple operator. You just take a record and then you process it, become another record, right? So map. And then in Flink, one thing that you can typically do is you can say, so here I've illustrated the events in like orange and green, right? So you got orange events and green events. So here you can say that I want to do a window function, something that Lincoln was talking about, right? So you want to say within a certain time period, how many of a particular event happens. Then the top one is, let's say, count how many green events have happened. The bottom one is maybe count how many orange or yellow events have happened, right? And then it goes into a sink. So sink is how you write into an external data source. So, Flink is not your only, it's an analytics tool, right? So it writes it somewhere so you can read it. So what we're going to kind of illustrate here is how Flink processes these records and how does it do it, right? So the little gray buckets at the top and bottom is the state that Flink stores. So for example, you say you want to count how many orange or green has happened, and as they flow through, you can see that it will start counting. So at the bottom, you can see it's seen 2, orange events. So you say, okay, I store it in my state 2. And you can see now it's seen 1 green event, so it's C2, right? And it flows through the job graph, and then it shows. So this is a state. So a very simple Flink job, just counting state, right? And then you see, okay, by the end, this is the state. So how do you kind of take a snapshot? How do you click the save button, right? So basically, a snapshot is you have a particular Flink state and you want to click a save button and store it somewhere, right? Some safe place that you can download from. So just imagine the same Flink job, a particular state. So we haven't processed all the records, right? So this is like what we saw just now, but then not all the records have processed. We've only seen 2 of the orange ones and the rest of the green one have still flowing through the graph. So what we want to do is we want to take a copy of all the state and store it somewhere safe. So I've just illustrated it quite simply. So usually you have a distributed file system that can store it, or like it can be OSS, it can be S3. That basically you can store it somewhere that you know you can download and access it from any point of time. So that's what a snapshot is. We just want to take the state and store it externally. But we want to store it, I guess this is a simple example where you only have one operator with state. So let's just try and understand it first, right? So in a real Flink job, your source will have a state. Your sink will have a state, and all of it will have its own individual state that you need to store at the same time in a consistent way. So the algorithm helps. The reason why we take it this way is so that the algorithm can take it in a consistent way, right? But yeah, we'll talk a little bit about how Flink does that. So one naive way, a very simple way that you can take a snapshot like this, is you just stop the job, right? You just say, stop processing all the data, and then you just save all the data into the S3, into your external file store. What's that problem? The problem is then, every time you take a save point, you need to stop the job. And that's bad, because that means, because Flink is a real-time system, right? You generate data in real time and low latency, meaning within minutes, within seconds, right? So every time you want to take a save point, you stop the job. That's bad, right? You want the data, you want your job to continue processing data even as you take a save point. So what Flink does is it uses this new algorithm. It's not new, it's just an algorithm that is invented in a paper. It's a Shandy Lamport, right? So it uses a certain algorithm to take this save point, and we're going to cover that now. So how does Flink take save points? So what it does is that I think this was also mentioned in Sintong's talk, right? So what it does is that it propagates checkpoint markers as records. What does that mean? So imagine the same job, external file system, our records, right? We haven't read the records in yet. So what Flink does is it inserts fake records, right? So these black items you see here. So this is like a record, it's like an event, but not really an event. It doesn't have any data in it. All it does is a checkpoint marker to say, at this point of time, the checkpoint belongs here. So what it means is that in a particular checkpoint, let's say checkpoint, the first black one and the second black one, so it says, I have processed up to this point in time. You know, when you're reading a book, you put your finger at a line, right? And you say, oh, I read up to this word. That's what Flink does. It says, I read up to this point. So what happens is that this checkpoint will flow through the graph, just like a normal record, and it will flow together with all the other records. So you can see here, as it flows, the records flow together with it. So your job will continue processing the data, and also continue processing checkpoints. So it does both at the same time. It doesn't stop processing. It continues processing as you do a checkpoint, right? So what happens is here, as you kind of see, so what happens is that now the operators have this checkpoint, right? So it says, oh, I've seen this checkpoint marker. I need to take a checkpoint. So what it does then is that it will do a checkpoint. And it will store the data that it has into the external file system. So this is how you get your checkpoint in Flink. And then let's say we continue processing. I guess it goes into the sink, so the checkpoint markers propagate to the next operator as well. You can see here now, okay, I've seen 2 orange events. Now it's 2, right? And then I guess, the checkpoint marker will continue propagating at the same time with the records, right? So they don't stop, they are continuous at the same time. One doesn't stop the other. Let's progress a bit more. Let's say you see continue. Okay, so now the top, I've seen a green. Bottom, I've seen 2 orange, right? And then now I take a checkpoint. So what you'll do, I guess it will create a new checkpoint. But then you can either store the old checkpoint or create a new one, up to you. But in this case, I'm just showing a replacement, right? So it replaces the old one with the new one. So what happens is that, in this case, it will say, okay, now I have this checkpoint, let me store the state, and then it updates it. And then it will continue processing as per normal to the sink. And then when I think here, what I wanted to illustrate here is a little bit of concept that I think Sintone talked on, which is alignment, right? So when there are two, if we go back a bit, right? Here in each operator, there's only one input, only one arrow going into the operator. So there's no need to wait for anything, there's no alignment, right? So the moment it sees the checkpoint, it will take a checkpoint. But then here, you can see the sink has two. So what happens is that there's a concept of alignment. If the top one is a bit slower, the sink will not take a checkpoint until the top one also produces the same checkpoint record. So there's this concept of alignment, so you need to wait a little bit. So it gets a bit more complicated, because in a real job graph, you wouldn't just have two. You have like 60, 100, right? You want to scale it. Like Flink, the one good thing about Flink is that you can scale. So you can go up to many, 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 many lines, and you need to wait for all of them to come at the same time. So that's the aligned checkpoint. So that's what happens is that you just wait for everything, and only after it's done, then you'll take a checkpoint, right? So when both, you've seen everything from a checkpoint record, from every single input, then you'll take a checkpoint. So that's alignment, the concept I wanted to introduce. Okay, anyways, so back to checkpoints. So now it's managed to take a checkpoint, and then you continue processing data as per normal, and then, you can trigger another checkpoint, and the same process will happen. Okay, so what have we covered so far? We know what a snapshot is. Snapshot is click the save button. We know how Flink goes about and takes a checkpoint. It uses this process called Shandyland port, right? So it inserts a fake record, it flows through the job graph, and as it flows through the job graph, you take a checkpoint. So that's how Flink takes it without stopping processing. It does processing at the same time, and it does checkpointing at the same time. Cool. Now what? I guess simple, right? No, not so simple. So there are different types, I guess there are different timings around the checkpoint. So what happens at checkpoint? So this table is a lot of numbers. Basically, I just wanted to show you what the different phases of a checkpoint is. So there are many steps to a checkpoint, and when you run a Flink job, you can say, let's say your checkpoint takes a certain amount of time to complete. Where does it spend the time? What is it doing with that time, right? When you open the Flink dashboard, it's a UI that comes with Flink. It will kind of explain a bunch of details to you on how a checkpoint occurs. So I just wanted to draw this because this is something that the Flink UI will show you. I want to explain what the different concepts are included here. What are the different times? Why got so many columns? What do they represent, right? They represent the different phases of a checkpoint and how long it spans in every single phase. You can see here it says the first one, the end-to-end time is 495 milliseconds. And then it spans 8 milliseconds on the synchronous part, 359 milliseconds on the async part. So how do we understand that? How does that map to the real process? So here at the bottom, I've just put a table. It's just an easier way of representing, so I don't have to draw this big table. And then let's explain, right? Consider the same job graph. Same graph, right? How do we populate the table? So the moment we create the checkpoint marker, that's the trigger time, because that's when we trigger the checkpoint. I think Sintone talked about it as well, right? So T1 is when we trigger the checkpoint. Then when it flows, and then it hits the operator, what happens here is that when it hits the operator, it will say, okay, I've triggered a checkpoint, and then it sits here. This is time T2, which is the checkpoint starts on the operator. So on the bottom, you can see I populated the start delay, right? Makes sense, right? It's the time that it delayed. So it had to delay from the start until now when it starts the checkpoint. That's the time delay, T2 minus T1. Simple. Next one, it says, in this case, there's only one. So where's the concept of alignment that I talked about earlier, right? Since there's only one, it doesn't have to wait to align. But if it needed to wait, then it will say, okay, I finished aligning, and then it has T3. So T3 minus T2 is the alignment duration, which is how long it needed to wait for all the inputs to align. In this case, it didn't need it to. So that's why it's T2 will equal to T3. But in a real case, like let's say you look at the sink, it will not be equal, right? So that's alignment. And then once you start the checkpoint, everything aligns. So you can start the checkpoint, you trigger the checkpoint. There's two parts to a checkpoint. There's a synchronous part and an asynchronous part, right? So we all know asynchronous and synchronous, right? Synchronous means it blocks processing, mean you cannot process. I mean, it makes sense, right? Because you have to take a copy of your state. So you cannot process while you take a copy, right? Otherwise, your copy will be inconsistent. So that's why there's a synchronous bit of it. You have to stop processing and take a checkpoint. So that's T4. So in most cases, this depends on the Well, it depends on your configuration of your Flink job, how long this will take, depending on your state backend. But that's something that I guess you can dive in a bit deeper next time. But the point is here, there's a synchronous bit to take a set point. Then after that, we need to copy it into the external storage, right? That's asynchronous, because you don't need to stop processing for that. You can continue processing. The copy can happen in the background. Well, kind of. It can happen while you're processing other records, right? So that's what it does. So asynchronous. So time it finished to take asynchronous. So there's synchronous and asynchronous. And then I guess the times are separated. So you can see, let's say your checkpoint is taking too long, you can go and debug where is spending the time, and then you can go and change your Flink cluster to fix that, right? So that's what it is. So I've been populating the tables down here. You can see synchronous and asynchronous. And then at the end, when the checkpoint is complete, it will say, okay, I finished. I guess there's a bit more details here where there's a certain acknowledgement. So once the tasks are completed, it will then send the acknowledgement to the job manager to kind of say, I've completed the checkpoint. But that's a detail you can dive to a bit more detail later. But the idea is that once you finish the checkpoint, you have an end-to-end duration, and that's T6 minus T1. And then it will say, this operator has completed the checkpoint, acknowledge. So you can see in the table, there's 2 rows. I don't know if you can see it because I'm here. But there's 2 rows. There's count 1 and count 2. Right? So there's 2 operators. If only one has completed, only the top one will complete and show acknowledge. So you need to wait for all of it to complete before you complete the checkpoint, because they all happen independently, right? So you need to wait for everything. Cool. Hopefully that gives you a better understanding of what a checkpoint is. So what we covered what a checkpoint, a save point is. We've talked about, I guess, how it goes about doing it and what these different details are. So hopefully in the future, when you need to debug, you can debug. Now we cover the different variations. What are the different types of save points, right? It's not as simple as just taking a save point. There are different types. So I just wanted to map it back to the table, right? So what are the variations? So we see here, the first concept I want to introduce is 2 different types of names for these snapshots, right? There's a checkpoint and save points, and as you can see throughout the talk, I've been using them interchangeably. Why? Because they basically represent the same process. The process that I talked about earlier is going to happen for both of these things, right? The difference is checkpoints are owned by the Flink job. So the job itself will trigger the checkpoint, and it's meant for the job to maintain the ownership, right? You're not supposed to look at the checkpoint, right? Checkpoint belongs to the Flink job. Save points belong to you as a user. So you trigger the save point, and then you use the save point externally. So it's external to the Flink job. Well, that's a rough boundary to help you understand. So the first one is the different purpose, right? So checkpoint, if you imagine, is just the job triggering and say, I want to save, and you can trigger that periodically. So the purpose of it is so that if, let's say, there's a network issue, right, it will recover from the checkpoints, right? Normally, you don't have to trigger anything. It automatically recovers so that it can continue processing. You don't need to interrupt. The Flink job will handle it for you, right? Save points the purpose is different. The purpose is for you to, let's say, change your job, right? I don't know, like if your job is not stagnant, let's say you want to add an additional operator, you want to update your job, you want to take a save point to save the state, and then you want to restore this state into your new job, right? So it's something that you want to take down and then start a new job, update the job. So the idea is that you can use the same state, but you can run it somewhere else. That's the portability of a save point. So your save point is for you to use externally, outside of the job. So yeah, so the way it's managed is lifecycle means who owns it. Generally, checkpoints are managed by the Flink job, right? Save points are managed by the user. There are some complications around this once you start diving into it. There's a claim, no claim, depending on how you start the save points. But don't need to think about that for now. You can dive it later. But the point is, checkpoints generally owned by the job, save points owned by the user. Who triggers it, right? Checkpoints, because the job owns it, so the job triggers it, right? So when you run, automatically, it can just trigger. Maybe every second or every minute, you can configure. Up to you, right? Because it's not free. When you trigger, you see there's async time, there's network communication. It's going to slow down your job. It doesn't stop the job, but it slows down the job. So periodic, how frequently you want to trigger is up to you. You can also manually trigger it, like for checkpoints and save points. All right, cool. There's another concept that I wanted to introduce here, which is incremental save points. So meaning, when you take a save point, if you imagine you have a lot of state, you have like, I don't know, it goes up to terabytes, gigabytes, terabytes of state. Every time you trigger a save point or checkpoint, you have to copy the whole state. That's very expensive, right? You have to copy the whole state and upload it. So what happens is that now there's this concept of incremental snapshots. So what happens is that you just show me what the difference is from your previous snapshot, right? So you don't have to store the whole thing. You just store parts of it. So checkpoints support that because it's owned by the job, it knows what files are available. The idea of save points is so that you can copy the entire save point file and restore from it a different job. So it needs to be all inclusive. It cannot point to any other thing, right? It cannot point to this checkpoint that happened 2 hours ago. Cannot. It must have it all in its local state. So we can optimize it, and there have been optimizations done. But the idea is that theoretically, it cannot support incremental, meaning you cannot have an incremental save point. Another concept, native versus canonical. I'll just cover this briefly. Happy for you to kind of talk to me a bit later if you're interested. But the idea is that you can, when you have state in Flink, you can have different types of state. You can store it on different kind of systems. You can use a heap backend or a RocksDB backend, or in the new one is force backend. So native means you take the save point in the format of the backend. Canonical means it's independent, and then you can kind of change backend. But anyways, the point is checkpoints is native, so you cannot change your backend. So it's meant for your exact same job. Whereas save points can be native or canonical. Native is faster to take. Canonical means you can change the state backend. It's a bit more complicated, but it's a bit more effort. So yeah, native versus canonical. Next one is, just now I talked about alignment. So imagine your job has a lot of alignment time, right? So you can say, oh, maybe I don't want to wait for everything to come. I just want you to kind of not align it. So there's a bit more detail around it and some technical design around it. I'm not going to go into details for now, but you can come and ask if you want. But checkpoints support unaligned, right? So you can take it in such a way that, oh, don't need to wait, just continue processing. Just don't need to wait for everything to be aligned, just take it. So you can do that, supports that. Save points doesn't. And then, I guess, I just mentioned again, the state backend change. Checkpoints doesn't support state backend change because it's native. And then, if you use a canonical save point, you can support a state backend change. Happy to explain this a bit later as well. There's a lot of concepts here. But I think the idea is these are just a brief overview, and you can kind of look into it a bit more deeper as you need to, right? Checkpoints versus save points. I think, so now I just want to cover a little bit on Flink 2. What's the difference to expect with Flink 2? So Flink 2 will bring quite a few changes, disaggregated state and async APIs. So just going to cover very quickly what it means for this checkpointing system. The first one is the mechanism itself, the propagation at the moment, no change. It'll be the same, right? So there's not going to be a change in the way we propagate it so far. There's a little bit of asynchronity happening. So the first one is Flink 2 introduces asynchronous state APIs. So it means that you can access the state asynchronously to the processing of your job. What happens is that you might have a little bit of a longer checkpoint time. That's one thing to expect, because you can be asynchronous in your processing, but you cannot be asynchronous in your checkpointing. So there's a bit of more alignment time. I guess you understand a bit more once you look into the API. There's another one, which is a new state backend. It's for streaming state backend, ForceDB. I think we talked about it in the keynote. There's a different state backend that you can store. The difference is, I think Yuan Mei talked about it, there are two main differences. One is, it's going to be faster to take checkpoints. Why? Because in disaggregated state store, your state is already in the bucket, in the external form, right? So that happens while you process the job. It moves it into the bucket for you. So you don't need to wait and say, oh, only move it during the checkpoint time. It will already be there. So I think not all, but some of it might already be there. So if you tune it correctly, you will have a faster checkpoint. You don't have to wait, because the state is already copied to the distributed file system as part of normal operation. So that also means, remember, I think you may talk about lower resource usage or more flattened resource usage, because during a checkpoint, you won't have a spike. It happens throughout the job as you're running. Second one is restore. So currently, when you restore from a checkpoint, let's say there's a problem, and then you restore from a particular checkpoint, it will then have to download all the state. Not true for disaggregated state store. So disaggregated state store don't need to download all the state. So because of that, it's faster, right? So I guess what do we see from this? A high-level picture is that how you tune your job, how you tune your ForceDB, and how you tune your async state API buffer size, so will be very important, because that will impact how long your checkpoints take. So I guess when you run your job, I guess you can play around. It's a new concept that we're playing around in Flink. So you probably need to tune all of these things for your checkpoints to be successful and fast. Otherwise, you have some issues when you're trying to stop or update your job. So yeah, so those are the changes. So let's, hopefully this one, happy to answer more questions later on as well. So just a quick recap of what we covered. So first one is we mentioned what is a snapshot. A snapshot is a copy of the Flink job state stored in somewhere safe that you can use. We also covered that how does Flink take it? It uses this kind of checkpoint markers, right? So like a fake event that it uses. And then different phases, remember we talked about a different time, so if you have to debug why it's taking so long, you can see where it's taking the time. And then we've covered a bunch of features that it support, and also a bunch of like checkpoints versus save points, whether it's managed by the job or managed externally. And then we also covered Flink 2 and how it's going to affect. So hopefully these are things that will be helpful for you if you're running and playing around with Flink, and happy to explain more if you have any questions as well. So yeah, thank you. Happy to take questions if there are any questions. Okay, cool. Otherwise, oh, sorry. Yeah. I can repeat it after.
Hello, I'm Jessa from BFE. What I want to ask is when the snapshot is used, for example, the failure, is it the full set is written by, processed by a new message or continue from the previous message?
So it will, yeah, good question. So if, let's say you take a save point and then your job fails and then you restore, right, from your state. So what happens is that, I guess it depends on your configuration, exactly once or at least once. That was touched by Sintong as well. So let's say you do exactly once, means you see one event, you only want to see it exactly one time. What happens, it will say, remember here, if I show you the picture, it's clearer. Here, right? So it's a distinct thing. So you can see that the black thing, it's like a fake record. So if you restore from that checkpoint, the first record it will process after that is the orange one that comes after it. So each event will only be seen once. So it will restore to the state, and then you'll process the next event. I don't know if that answered your question.
So if the process is rerun,
yeah,
it's possible to make to run from a new message or.
Meaning you don't want to see this message.
Yeah,
you want to move to a new message.
For example, the process is error after checkpoint 2.
I see.
Run new the last two messages or new.
Okay, I get your question now. Sorry. So it means that let's say there's a problem, you want to change your job to fix that. You can do it. So you can change your job. Or if you don't want to change your job, you want to process something else, you can. So what you need to do is you need to change your state. But there's a way to do it. It's like the state migrator API, or you can drop the state. There are a few ways of doing it, but it's not a normal, as you can imagine, it's not a normal use case. Because usually we want to make sure you continue. But if let's say you want to say, I don't want to continue, I want to do something else, that's also possible. But you need to, the two ways that off the top of my head is, one, you can just take the save point, so you can take whatever is already there, and then you can change it. You can modify it. It's up to you, because it's just code. You can load it and change it. Or, second one is you can say, I want to drop the state of just the source. So the source read from somewhere else. But then everything else stays the same. You can do that. So the way you do it is by changing the UID. There's a tag that attached to each state. And you can say, I changed this UID, so it's a different state now. You can do that. But then you need to kind of change your Flink job. And there's a few techniques. I'm happy to talk about it if you're interested.
Okay, thank you.
Yeah, good question. Yeah. Any other questions? Oh, yeah. I think just one more question, because might not have enough time. Yeah.
They will get a merchandise after giving
is
you
it?
a question. Yeah, look at that.
Do I get merchandise for answering a question? Sorry.
Yes, why not?
Yeah, sorry.
Okay, so just want to confirm on this page,
Yeah.
right? And just want to clarify about the save points. Would that be when we do the save points, that fake records will be generated, and we will need to wait until the end-to-end, and then we have those save points, or what are the differences when we are doing the save points when we look at these fake records?
Sorry, just to understand your question a bit better. So you're saying that when you take a save point, do you need to wait for everything to complete before you complete the save point?
That's correct. Because like save points is user triggered, right?
Yeah.
So when I do the save points, will that means the fake records will be generated, and we have to wait until the whole process and we have those save points, or is there any difference with the checkpoints?
Yeah, okay, I understand the question. Thanks for the question. I think there's no difference in this process. So the way that it happens will be the same. But there's a slide, I didn't cover it in my talk, but there's two types of save points. So there's a normal save point where you want to take a save point and your processing wants to continue. So there's records that come after the save point. There's a second one that you can say stop with save point. So you can just say after you take the save point, don't process any more records, right? I don't want you to process. So you can say, imagine the black one, you can say don't read anymore, no more, right? I want to change the source. I want to move it somewhere else. So you can trigger that. And if it does that, then it's slightly different. So what happens is that once it takes the save point, it will stop processing after that. You will say, I'm not going to process anymore. So that's one slight difference. But just to answer your question, checkpoint and save point, the process will be the same. But you will need to wait for the fake events to flow through your whole graph. Then only you have the save point. But you can continue processing records. Yeah.
Okay.
But yeah, you have to wait for it to flow through. Yeah, there's no difference. I mean, even on the stop with save point one, it will also flow through. It's just that it might be faster because it stops processing after.
Okay, thank you.
Yeah, good question. Thank you. Cool. Yeah, thanks for your questions, everybody. I'm happy to answer more questions after if you want as well.
Yes.
During the breaks. Yeah.
Thank you so much, Mr. Hong Liang Teo.